Hi, this is E here. I made this document, version 0.2 presentation, to capture where this project is as of today. It has a lot of information about the architecture, how things are structured. I think this is enough for someone who is not familiar with the project and take a deep dive. But I also want to make this video as a complementary information for this presentation. I want to highlight something and also want to add a few points. I'm not going to read through these documents. If you look at here, I think there's something I want to talk about the motivation behind this project. So if you go to YouTube, if you consume a lot of videos, gradually you will find some favorite channels. You will follow them, and you will consume a lot of videos from the channels. But over time, the channels contain a lot of videos. Over the years, take any popular YouTube channel, they have hundreds, if not thousands of video across span multiple years. And that gives you a challenge that is very difficult to track down some topic or go back in time and find something that the host actually talked about. It's kind of a buried in the stack of all the videos. But it also offers an opportunity if you have a good way to connect that information and analyze that information and present it in a more chewable way, you actually can get some more value from the channel because, for example, a host's viewpoint of certain topic might change over the years, or if this is a product review channel, for example, car review channels, the cars evolve over the years. And with that kind of information in mind, if you could search through the channel and find the videos on certain topic, on certain subjects, and not just on the title, but actually dive very deep into the content of the video, that will become a very powerful tool, basically speed up your consumption of the video content. So that's the motivation behind this. There's a need. I think there's some value of creating this kind of search or LLM-enabled understanding of the videos. RAG comes into consideration because we're talking about a confined. There is you draw a circle in this universe. You don't really care about all the stuff you don't follow in this YouTube videos, but you draw a circle and only those you dig very deep into it. So RAG comes into this solution because it can index those specific channels for you and trying to understand the content of the video. It doesn't really understand the content of the video per se, but YouTube provide a lot of transcripts. A lot of videos have transcripts. So if you could index the transcripts and feed LLM with the transcripts and generate summaries of extract keywords, then you can use LLM as a powerful tool to understand the content of the video. And on top of that, you build a search and you have a conversation with LLM. That will make the consumption of the videos, large quantity of videos, becomes much more efficient. So that's the motivation behind this project. I think you can read through the doc and figure out how to use it, how every component is structured. I just want to highlight a few interesting points. One of the issue is extracting information out of YouTube is that if you are sending a lot of the requests from the same IP address, you are very likely to get banned. just block your IP address. Don't return anything. So if you want to actually use this code, you will need to figure out a web proxy solution. I have been using WebShare. It's pretty cheap for this project. I extract information for over 9,000 video transcripts. It works pretty good. But that's one catch. In order for this to actually work, you will have to figure out a web proxy solution for yourself. Another interesting thing I run into is, where is this? Decisions and yeah, which LLM are going to choose. This comes to the hardware limitations. I'm using a desktop to run in the system. I only have a GPU with 8 gig memory. That's severely limited what kind of LLM, open source LLM I can use. I'm going to use Green with 7 billion parameters. That's not a very powerful LLM. And then I also have OpenAI access. I could send the query to OpenAI. I'm trying to do run the operation over there. But the challenge is if you send a large text to OpenAI, one, it's going to be very slow. Two, it's going to be very expensive. So open source local LLM is the cheapest way to access the LLM power. OpenAI can become expensive very quickly. But the OpenAI does have more powerful models. For example, if you want to analyze a full transcript, it's probably going to be very slow. But if you only use OpenAI to analyze, for example, evaluation of the results, or use OpenAI to parse the user query, that might be might work. Okay, that's the first decision. So which LLM are you going to pick? The system is actually allow you to config and swap the models in and out. You can pick whatever you want, but just make sure your hardware actually support it. The second decision I had to make, is that there is I don't just want the capability to search, find a specific video, but also the content inside of the video. So I'm trying to leverage the chapters that the host of the YouTube channels actually created by themselves. So if you go to a lot of videos, the video have chapters, basically from the first second to maybe a few minutes later, there's one chapter. Say this is an introduction, and there is blah 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 blah. So that helps to slice the transcript to multiple parts. But not all of them have chapters. So the solution I have done is basically based on the statistics of the chapter size. I will break any transcript that the video, if the video doesn't offer chapters, I will break them into sections. And the section size is based on the typical size of the chapters. Decision 3, two-phase retrievals. Phase 1 will search video summaries, and phase 2 search video section. This is very obvious because on the first identify where the video is, where the question will lead to. Is it going to be this video, and then try to find where exactly this content is. Query analysis through LLM. This is also very important because, say, the user asks a question, and how do you turn that question into the query? that can be tricky if you are using something like regex. You're trying to identify the pattern, then it's very difficult because the system is going to be very brittle. Here, LLM becomes very handy because you can actually understand the input from a user and turn that into kind of a standard types of queries, and that will fit into the search system and trying to find all the videos, the titles, keywords, and then that will fit into the LLM answer machine. LLM will incorporate that and come up with an answer. And then CPU only files is a compromise because I just run into a lot of issues. If I want to turn on GPU acceleration for this library, I ran into a lot of issues with hardware, library dependencies, etc. But the speed up is not significant enough for me to actually resolve the problem completely. Because, for example, if the CPU version will get you somewhere 10 milliseconds response latency, GPU might get to like 1 or 2 milliseconds. That percentage-wise is very high improvement, but even CPU is only like tens of milliseconds. It's actually super fast. So that is one of the compromise I did. Last but not the least is the benchmarking part. So benchmarking part, it comes down to now the system is running. How do you evaluate the system? The obvious way is you just chat with the system, ask a question, get an answer, ask a question, get an answer. Immediately that will lead to the thinking of there are probably 2 metrics you care about the system. One is latency. So you ask a question, how long do you get your results back? Whatever it is, how long does it take it to answer? So that's the easiest part. You can just run the questions and get answers and get the average latency. The second part is way more tricky because how do you evaluate the quality of the answers? You ask a question to the system, and the system come back with a brief summary and then a bunch of links to different videos. How do you know that they actually the result is relevant and is actually get you something valuable out of the channels? The thing I have done so far is 2 tricks. One is automatically generate tests and use LLM to evaluate the results. Say, if we go through here, so we pick some sample videos from all the channels and then extract the sections and save that content. Basically, now this is a bunch of transcripts and sectionized transcripts from each channel. And then we use I use LLM to analyze each video, each section. So try to understand the content and prepare some questions. So generate a bunch of questions. Some question asking about the entities of in the channel, topic, comparison, list and count, meta information, and then this will be generated. Say this is generated by GPT 4.0. This will be the tests that will be run later. So imagine you have a list of questions, and this question will be run against the system, and you get an answer back. So because you extract every question out of the original transcript, so you know where it is, right? So you kind of expect the answer should contain the reference or link to the original video or section that you actually generated the question. So now you have a way to compare. So run the questions, get the answers, and then use LLM to evaluate, is this answer actually relevant to original video. So that's how I did it. As you can see, the results is okay. It's not perfect, but I think it's usable now. The latency, majority of the latency is actually coming from answering. So if you run the answer, it probably takes the system to 1 to 2 seconds to figure out the answer. Those trying to embed, analyze, search, filtering, everything happens at a milliseconds level. But once you feed that results into LLM and try to come up with the answer, that becomes like 1 second, 2 seconds, 3 seconds operation. And the relevance is decent. So at least in GPT 4.0 minis viewpoint, the answers which passed its judgment 63%, and the keywords matches 81%. So you can see that it's workable, it's usable, and the latency is also acceptable. But if you take a step back and think it over, you realize the limitation of the system. And I want to talk a couple of things I want to improve in the future. One, this is one session, one user asking the system, and it takes like multiple seconds to get an answer. Well, imagine you have 1 million users asking the system simultaneously every day. How much hardware and how much resources you have dedicated to those, and how do you handle that workload? I don't think this is ready for that. This is far from ready for that. So how to make the system more scalable and efficient so it can actually serve a lot of concurrent sessions? That's a tricky question. I don't have an answer right now. The second one is because of the way I design the sectioning and sampling the keywords, summaries, it's kind of breaking the video down a little bit. So imagine you have a 20 minutes video breaking down to 5 sections. Each section, I'm taking all this building index on each sections. Yes, the search capability is able to lead the user to specific sections. But the problem is, if you are a human, you watch 1,000 videos from a channel, the knowledge you gain, not just fragmented sections, you actually can build a connection between different parts, different topics, even across different channels. So naturally, the knowledge you can gain from it is not a list of bullet points. It's actually something like more like a graph. So this comes back to the systemic limitation of the rack here. There's another open source project that is doing, it's called a light rack. It's building a graph out of the sampled information and trying to feed that into LLM, have a way better understanding of the content. So I will try that later. The third one is because the hardware limitations I have right now, the open source model I use is actually not very big. Imagine I have a much bigger GPU, then I can try out much bigger models. Maybe those models will do much better job in extracting and the keywords, understanding the content, make summaries of the transcript, or even better at the validation of the testing results. So I think that's also a very promising direction to explore. So to summarize, there are top 3 things I would like to try out. Number 1 is find a bigger GPUs, try out bigger models and see what happens. And then try out a new way of building the rack. As I mentioned, the light rack, maybe a very promising candidate. Um, and then I forgot the third one I wanted to mention. This oh yeah yes sorry the scalability issue. So how to make the system more scalable, that it actually can be productionized. So that's the next step. All right, thank you for your attention. See you later.